Solve Leetcode problem 2429, minimize XOR. Given two positive integers, nums1 and nums2, we need to find the positive integer x such that x has the same number of set bits as num2. So we need to understand about the set bits first. So set bits is just needed to count how many ones inside the binary representation of this number. So for example, this is number 5. So number 5, the binary representation is 0101, so the set bit is for this one and this one. So number of set bit is 2. Yeah. So this is the first expression. X has the same number of set bits as number 2, so it means it will have 2 set bits. The second condition is that the value x on nums1 is minimal. So we need to find a value. For example, this value x is 3. 3 x on 3 should be minimal. It is a 0, of course. 0 gonna be minimal. Yeah. At first sight, you might think this problem must be really difficult because we are familiar with plus, minus, multiplication, or division, but we are not familiar with bit manipulation. Yeah. So when it comes to bit manipulation problem, we have to try all the examples to check if we can find some solution. Normally it might have a solution of a greedy idea, or it has the solution of we put the numbers first into binary representation and to check if there's some patterns we can find in the number. If we can find, it might be easier to solve. Yeah. And nums1 2 is 10 to the power of 9. So it means it can be represented by a 32-bit number, because 32-bit is enough to, yeah, that number would be more than 10 to the power of 9. Yeah. Now let's just try some examples. Let's try the first example. So if num1 equals to 3 and this num2 equal to 5. Yeah. So this 5 representation is gonna be 0, 1, 0, 0. Yeah, let's try to just use the 4-bit. And for this 3, it's gonna be 0, 0, 1, 1. Yeah. So for this one, how many set bits? We can calculate it easily. So the set bits is 2. So this means we're gonna find a number x. So for this number x must have 2 set bits. Yeah. So what is the smallest number with 2 set bits? So it must be 3, right? Yeah. So for example, it must be 3. This is gonna be the smallest number with 2 set bits, but that is not the result yet. We have to check with this num1. Yeah. So for example, this num1 is 0011. Okay, if we set x as 0011, so the result is 0. It is the minimum number, so we're gonna return a 3. Yeah. So it seems we can solve it by comparing with this nums1 and x in the binary representation. Yeah. But what if this x is just yeah? So for example, we are not calculating the x yet, but we are going to check the nums2. Yeah. Let me check the nums2. Yeah. But nums2 is with the 2 set bits. Yeah. But what if nums1 is not 0, 0, 1, 1, it is 0, 1, 1, 1. What if this number is 7? Yeah. But our set bit is 2. So what we can do for the number of x? Yeah. So for the x, we can only prepare 2 set bits. Of course, we're gonna use the greedy idea. We're gonna prepare x in this position and this position. Right. Yeah, because this position, this bit x on with this one, it's gonna be 0. This one with this one, it's gonna be 0. But the last bit is gonna be 0 because we only have 2 set bits. Yeah. So this means we can use a greedy idea to solve the problem. If there is a less set bit, it's gonna be like this. We're gonna check from the left to the right. If there's a 1, we're gonna record a result. It's gonna be this one gonna be 6, and this one gonna be this one gonna be 4, and this one gonna be 2, and the last one gonna be 0. Yeah. But what if yeah, what if this number 2 is a really big number? Let's check. We have another 2. Let me make it simple. Yeah, if we have 4 ones like this one, and the number 1 is a 6-bit number. Yeah, we have number 1 have 3 ones and number 2 have 4 ones. It means we have more ones, right? So what we can do? So first of all, the idea is the same. We're gonna check. We're gonna check from the left to the right. So it's gonna be 0, 0, 0, and from here, we can set it 1, 1, 1. So how many ones we consumed? In total, we have 4, but here we just consumed 3 ones. It means we have another one. Yeah. So where can we put the another one? It must be at this position because we're gonna get the smallest number x. Yeah. So this one must be here. So this is the final result for the x, and x XOR number 1 gonna be the minimum. Yeah, because this one would be 0, and we just left another one. This one gonna be 8. So the result is 8. Yeah. Now I think we have a solution to solve the problem. Basically, it's the greedy idea. Yeah. So first of all, let's just count how many ones for number 2. We can use bit count. So number 2. Bit count. So we're gonna use it to count how many ones in number 2, how many set bit in number 2. Yeah. Now we're gonna prepare an array. So the array would be the binary representation of number 1. We're gonna check the array because we're gonna I think array is okay, but you use the string, it is also okay. Yeah, but let's just use array. So it should be list bin. Yeah, because we need the binary representation, so I want to put it into a string bin with the nums 1, and I need to take out the 2 characters, which is not binary character. Yeah, and then I'm gonna use a zfill because I need to prepare a 32-bit. Yeah. Now let me print out what is A, and let me explain this one. So I just gonna return a 0 first because I want to check what is that A. You're gonna check it. You're gonna see it easily. Oh, there's a number 2 dot bit count. Yeah, number 2. Definitely this gonna be wrong. There's no number 2 inside. Yeah. So this is the array of A. As you can see, this is a 3. This is a low bit from 1 and 1. This is 3, and in total there are 32 bits for this array. Now I'm gonna check the result by using this array. Yeah, I think there are 2 ways. I can reverse the array, or I will keep it like this, but it doesn't matter. Yeah. So let me put it like this. So the array for number 1 would be like this. Yeah. Now I'm going to check the array from the left to the right side, as I explained earlier. If I find a 1, I'm gonna record a result, and this one will be -1. Yeah. Now let me just check the array A. So for I in enumerate A, I'm gonna check the this number, but this number will be a binary string if this number is 1. So what I'm gonna do, I'm gonna record the result. So from the beginning, the result would be 0. Yeah. If it is 1, so the result would plus equal to, I'm gonna use a binary check. So for the number 1 would be 52 with it should be 32 minus I minus 1. Yeah, because I didn't reverse the array, we have to check. So for example, at this position, so the index is 30, right? Yeah, because the length of the array is 32, so this index must be 30. So 32 and the total length minus 30, it is 2. 2 minus 1, it is 1. So 1 shifted to left to one position, it's gonna be 2. So the result of this one gonna be 2. So I put it inside of the result. So similarly for the next one, yeah, if I have enough ones, so I have to check if I have enough ones, and ones, this means 1 smaller than 0. Yeah. Up to now, I can check the result if this ones equal to 0, so I can return the result safely. Yeah. So for example, I have this ones is 2, so I prepare a 1 and prepare another 1, so I can return the result easily. So otherwise, if I still have ones, so I'm gonna count the array from the right to the left side. Yeah, because I want to keep the value as small as possible. Yeah, so let me use another enumerate. So for in enumerate, but currently I want to reverse the array. Yeah, because if I reverse the array, the calculation would be easier, not like that. Yeah, so I just keep it to different calculations, but it's gonna be the same. Yeah. So now if I reverse the array, so this 1 and 1 would be at the beginning, and I need to check zeros. So if n equal to string 0, it means I find a position. Yeah. So if I find a position, I would to record a result. So it would be 1 shifted, shifted with I. Yeah. And because this is a bait operation, shifted left to I. So for example, this one, if I find a position of this one, so now because I reversed the array, this index is 0, 1, and 2. So I shifted 2 positions, it's gonna be 4. So it means it should be okay for the result. And finally, I just need to return the result. So this is the entire code. It is not so long, but you have to use a greedy idea to solve it by using mathematics skills. Let me just run it to check if oh, it is because I didn't minus ones. So the ones should minus 1 because I consumed a 1, and here also the same, I consumed a 1, ones would be minus 1. Otherwise, you can never get it right. Yeah. No, there's still something wrong with it. I have to check. At least I passed 3 testing cases, and I have to check this one. Yeah, I got a really big number. It means something is wrong. Yeah, let me first check from here to check the result, if my result is okay or not. From the first operation. Yeah, so currently I can get a result of 1. From here I can get a result of 1. So with with this number, I believe with number 1 and the number 2. Yeah, I want to check how many ones for this 12. So I want to print out the 12 how many ones, and I also want to get the array of A. Yeah, let me just print out these values and check, analyze why it is wrong. Yeah, so currently from here my result is 1. So I can get an array of this one because this is for nums 2, this is for nums 1, nums 1 is 1. So here is a 1, and the nums 2 is 12. Yeah, and I count how many ones. Nums 2 dot bit count 12. For number 12, the bit of ones should, yeah, because I minus a 1. Yeah, because from here I still have 1 left. Yeah. Let me check how many ones from here. Yeah, so 12, it should be 2 ones. Yeah, because I consumed 1, so I left one behind. Yeah, it seems okay. Yeah, it seems okay. It means I needed to put a 1 at this position, but I didn't put it. I needed to check why. First of all, I reversed it, and yeah, I didn't check from here. I have to check. There's still ones. Yeah, if it is equal to 0 and still it has ones, I need to get the result, and ones should be -1. Now let me run it. Yeah, as you can see, it seems right. Now let me delete the print and submit it to check if it can pass all the testing cases. Yeah, as you can see, it's pretty fast and it works. And the time complexity is just, let me check the number. 10 to the power of 9, it is just 0.01, because 32 is just a constant number. It didn't take so much time. That is why it is so fast. So the basic idea you need to understand is that you need to use some data structure, or maybe array, or maybe it's a tree. I think it still works. But you need to use the greedy idea to check the ones, like from the left to right, and check the zeros from the right to the left if you didn't reverse the array. Yeah. Thank you for watching. See you next time.